All right, so continuing along with chapter 9, we're still talking about functions. And if you remember in 9.1, we talked about what a function is. So a function is a relation, so where you have x and y coordinates, where every x has exactly one y. So you basically don't want to repeat any x's when you're looking at a set of ordered pairs or an xy chart. We also saw some functions in the form of equations. And so one other thing we're going to see with those is function notation. And this is just a specific way that we're going to be writing our functions as an equation. So instead of what we normally see, I cannot spell today. Instead of having something like y equals 3x plus 1, that's what we normally see. We would graph the y-intercept and the slope. We're still going to have the y-intercept and the slope, but function notation is going to replace this y with an f of x. And so what f of x is f parentheses x equals 3x plus 1. So I'm going to keep the rest of it the same. We're just replacing this y with f of x. And so this is called f of x. All that means is that this equation is a function of x. That means that we're plugging x's in, and we're not going to have other variables over here. We're just going to have x's. One big thing to keep in mind is that even though there are parentheses here, this is not multiplication. That's a really kind of common mistake with these, is seeing parentheses and thinking that that's multiplication. But again, this just means f of x, or a function of x. And so x is the independent variable. So that's what we're plugging in. That's what we're changing the value of most of the times. And y, or f of x, so these two are exactly the same thing. They're interchangeable, is the dependent variable. And so the way to remember that is that f of x, or y, depends on what we plug in for x. So this is an important thing here. So I'm going to put stars around this, that y is the same thing as f of x, because we're going to see some examples where we kind of rely on that fact. First thing we're going to do with these is evaluate some functions. And so this is stuff we've kind of seen before, where you plug in different values for x. These are just going to look different because it's in function notation. So let's go ahead and look at our first example. And so this one, we're told for f of x equals 6x minus 2, we're going to go ahead and find a couple different things. First one is we're going to find f of 0. So what this is telling us to do is we're going to, now if you notice, we have replaced the x that's usually on the inside of the parentheses with a 0. So we're going to replace this x in our equation with a 0. So we're going to have 6 times x, or 6 times 0, and then minus 2. So we're just plugging in whatever number we have in those parentheses for x, and I'm always going to put it in parentheses when we plug it in. For 1, when you have negatives, you're going to want the parentheses there, because it's going to make it look nicer, and it's going to make sure that you evaluate it correctly. So now with order of operations, 6 times 0 is 0 minus 2, and 0 minus 2 is negative 2. So what this is saying, f of 0 is equal to negative 2. This is actually a point on this line. So this 0 is our x, which means that this negative 2, well, that's our f of x, which is the same thing as y. So this corresponds with the point 0, negative 2 on the line. Okay, let's go ahead and try another one of these. Let's go ahead and do, let's get a new page here. Let's go ahead and find f of 1/2. And so again, we're still using that equation, f of x equals 6x minus 2. So let's go ahead and again replace this x with our 1/2. So we're going to have 6 times 1/2 minus 2. Well, this one's pretty nice to multiply because 1/2 of 6 is 3, and then 3 minus 2 is 1. So f of 1/2 is equal to 1. And again, that means you have the xy coordinate 1/2, comma 1. All right, now let's try one that's a little bit different. So this one we're given f of negative x. So we're told to find f of negative x. And so we're going to do exactly what we did in these other problems, but in this time, instead of plugging in a number, we're plugging in negative x. So we're going to have 6 times, I'm going to put negative x here, and then minus 2. So another reason why I like putting parentheses is because if we hadn't used parentheses here, it would get kind of messy when you have that negative x. Now let's go ahead and simplify this. We can't get this down to a single number because of this x. But if we have 6 times negative x or 6 times negative 1x, we get negative 6x minus 2. And so all this one does is gives us a slightly different binomial than we started with. But again, we're always plugging in what you see inside the parentheses. So let's go ahead and try another function. So for f of x equals negative x squared minus 4x plus 1, find the following. First one here is f of negative 2. So again, doing the same thing, we're replacing x with negative 2. So every time I have an x here, I'm going to put parentheses, but everything else stays the same. So I'm going to bring down this negative, oops, put parentheses for that x squared. So see how this is our first term that we have right here, except our x has now been replaced with parentheses. That is so that I can plug in our negative 2. And then continuing along, we're going to have minus 4 times x. So we're going to put in a negative 2 there. And then at the end, we have a plus 1. So all we've done here is we have taken our x's and replaced them with negative 2's. Notice how everything else is the same. The only thing we've done is added in those parentheses. Now let's go ahead and simplify this. So I'm going to go vertically for this one so you can kind of line everything up. Okay, for this first term here, this is the tricky part of this one. We have a negative out in front, then a negative 2 being squared. So remember, we want to do exponents before we multiply. Think of this like a negative 1 out in front. So first thing we're going to do is we'll keep that negative. Negative 2 squared is negative 2 times negative 2 is positive 4. But that negative that we had out in front, that kind of extra negative, makes that 4 negative. Now, our next part, we have minus 4 times negative 2 is negative 8. Now, you can write this a couple different ways. You can think of this up here as negative 4 times negative 2, which is a positive 8. Or if you do it this way, we're going to subtract a negative, and it'll become a positive either way. And then we'll bring down that plus 1. Now, we're going to have negative 4 add the opposite, so plus 8. Negative 4 plus 8 is 4, plus 1 is 5. So this one's tricky when you have those negative numbers, but just remember exponents before you multiply and plug everything into parentheses. Let's try one more here. And this one's going to be one that we'll just simplify because this is f of a over 4. So again, we're going to replace these x's with a over 4. So I'll keep the negative in the front. Now we have an x squared, so I'm going to put parentheses squared. And now we're plugging in a over 4. So I'll put that in the parentheses. And then we have minus 4 times x, so minus 4 parentheses a over 4. And then we have the plus 1 at the end. Again, these x's became a over 4. And now, same thing here, we want to make sure we square inside the parentheses before we apply this negative. So I'm going to leave the negative out in front. And now a squared, so you can think of, let's do this, a over 4 squared. This is the same thing as a over 4 times a over 4. And then multiplying straight across, a times a is a squared. 4 times 4 is 16. So we get a squared over 16, and I'm just going to leave that negative out in front. And then for this next one, we have minus 4. I'm going to write this as 4 over 1 times a over 4. Now, there's a nice thing that happens here. These 4's cancel out, and then we're left with a over 1, which is just a. So we're going to have minus a, and then plus 1. Now, this is as simplified as this one gets because this first term is an a squared. So it's not like terms with this a, and this 1 doesn't have an a in it either. So these are not like terms. So this is as far as we can simplify this. All right, and then let's try one last set of examples. So for this one, we're given g of x. So notice how this is a g non-f. Same thing, it's still just a function of x equals 5x minus 1. We want to find g of x plus 2. So this one's weird because we're plugging in a sum, but similar thing, we're going to keep the 5 in the front, times x, so times, now we're going to plug in x plus 2, where that x was, and then minus 1. And now we want to make sure that we simplify, so let's go ahead and distribute. So we get 5x plus 10 minus 1, and then combine, and we get 5x plus 9. So that's what we get when we plug in x plus 2. And that's something you'll see a little bit more in 126 because you'll be changing some functions and looking at the graph to see what this plus 2 is actually going to do. It's going to shift the graph to the left 2 units. So you'll see that a little bit later, but not in this class. All right, and then I'll go ahead and do part B over here. Part B, we're looking for g of 2x minus 2. So exactly like what we did over here, we're going to replace this x with 2x minus 2. So we're going to have 5 times 2x minus 2, and then minus 1. And again, make sure that you simplify. So let's distribute. So we get 10x minus 10 minus 1. And so we get 10x minus 11. So that's what we get when we plug in 2x minus 2 for x. All right, now let's go ahead and do the same thing, but in a slightly different way. So in this next set of examples, we are told for each function, we're going to have 3 different ones. Find f of -2. So for this one, we're not going to be given an equation. This first example, we're given a set of ordered pairs. So we're told that f, or f of x, is equal to the set of points 0, 5, -1, 3, and -2, 1. So since we are looking for f of -2, remember that our normal function notation is f of x. So that -2 is replacing x. And so what we want to do is we want to find where the x is -2. And so our x coordinates are the first guys. And so our x is -2 here. And so then this is saying, what is the y value when x is -2? Because we're looking for f of -2, which is the same thing as y. So then when when x is -2, our y value is 1. So f of -2 equals 1. Let's try another one. Going back to number 1 here, if we would have had f of 0, well, f of 0 is 5. And our other one here, f of -1 is 3. So notice how it's always the x and then the y, the x and then the y. All right, so number 2 here, we're given a chart. We're given the x and then f of x chart. The x coordinates are -4, -2, 0, and 2. The y's, or the f of x's, are 6, 4, 0, and 4. Now, if we go ahead and again, we want to find f of -2. So when our x is -2, what is the y? Well, if we have x as -2, that's this point right here. And when x is -2, y is 4. Okay, number 3. This is the last type of problem you'll see, and we saw these in 9.1. In our first circle here, we have -4, -2, and 0. And then in our right circle, we have 2, 3, 8. Sorry, that first one's a -2. And then there's arrows going just directly across. And remember, those arrows don't have to, actually, let me do this. Those arrows don't have to go directly across. So let's do this, just so you can see what it looks like. Okay, so now what we're gonna do is, again, find f of -2. So when x is -2, what is the y? And remember, when you're looking at these, kind of like with an XY chart, the x is on the left, the y is on the right, or the f of x in this case. And so when our x is -2, that's right here, our y coordinate is 8. So make sure you're always looking at the x, depending on what you're given, because we will see somewhere you're given the other information. For this one, we're given the x is -2, so make sure you look at the x for -2, not the y. Because there is a y coordinate of -2 here, but we didn't even need to use it. So when x is -2, y is 8. All right, so now I'm going to do a very similar thing, but we're going to do it using a graph. A lot of these questions are really similar. They're just, you're given different information each time. All right, so for this one, we're told to use the graph to find the following. So let me go ahead and write down the problems first, and then I'll draw the graph, and then we'll kind of go through them together. Number 1, we're told to find f of 2. Number 2, we're told to find f of -1. And then number 3, this one's going to be where it's a little different. We're told to find the value of x when f of x equals 2. And then lastly, the value of x when f of x equals 4. All right, so now I'm going to go ahead and graph draw the graph that we were given for this one. So for this one, you want to go out. Ooh, that is crooked. You want to go out to about 4 in each direction. So I'll go out 1, 2, 3, 4. 1, 2, 3, 4. 2, 3, 4. And then 1, 2, 3, 4. Okay, and now we're given the points -1, 0. So over here, 0, 1, 1, 2. Let me label these guys really fast. And then a couple more points here. So we've got 2, 3. And 3, 4. And I'm going to draw the line through those. Yeah, that goes roughly through there. All right, so first thing we're told to do is find f of 2. So remember, this 2 is the x coordinate. So they're saying when x is 2, what is the y? Well, if we go to, that's a 1. When we go to 2 on the x-axis, what is the y coordinate? Well, the y coordinate is 3. So we go to 2, and then our y coordinate is 3. So f of 2 is equal to 3. And again, remember this means that the point 2, 3 is on our graph, which it is, so we have it right there. Next, we're told to find f of -1. So if we go to, let me erase this a little bit. If we go ahead and go to -1, what is our y coordinate? Well, this is the point right here. So when x is -1, what is our y coordinate? Our y coordinate is 0. All right, now this is the part that we haven't seen before. This is just kind of the flipped version of what we've been doing. So this one is actually a little bit more clear. They tell us to find the value of x, so we are looking for x when f of x equals 2. Now remember, f of x is the exact same thing as y. So they're saying, what is x when y is equal to 2? Well, let's go to where y is equal to 2. That is going to be right here. And so the y is equal to 2 at this point. So our x coordinate right there is 1. And so for this one, I'm just going to say x equals 1. I believe in your homework, you'll probably just have to put 1 into the box. You shouldn't have to put x equals 1. All right, so then for this last one, again, we're looking for the value of x when f of x or y is equal to 4. Well, if we go to where y is equal to 4, that's going to be up here. And then the value of x at this point is 3. So the value of x is 3. All right, so that's how we find values of a function. Now we're going to take this and write equations of lines in function notation. So writing equations of lines. Well, let's change this. We're going to say writing equations using function notation. The reason why I changed it is because we're going to see some equations that are not straight lines. We'll see one that's non-linear, so we'll just write it. Equations using function notation. And so first thing you're going to do is solve for y. So we want to get y by itself. And so if we were looking at a linear equation, that means we'll have y equals mx plus b. Again, we'll see one that's not linear, but this y will still be by itself. And then second thing you want to do is you're going to replace that y with f of x. So all that means is instead of a y here, we're going to have f of x equals mx plus b. All right, so let's go ahead and look at some examples. Let's go ahead and do this on the next page. So we're told to write in function notation and then find f of -1. So number one here, we're given 2x minus 5y equals 4. And so for this one, you can notice that we have an x and a y. They don't have any exponents on them besides the ones that we don't see. So this is linear, which means that the graph is a straight line. So let's go ahead and solve this for y. So first thing I'm going to do is subtract 2x from both sides. So we get -5y equals -2x plus 4. So notice how I'm putting it in mx plus b form. If you wanted to flip it around, that's fine. But remember, if you're graphing, it's a little bit easier if you have it in the correct form, so you know which is the slope and which is the y-intercept. Now let's go ahead and divide everything by -5. And now we have y equals negative over a negative is a positive, so we have 2/5 x. Now a positive over a negative is a negative, so I'm going to put minus 4/5. I almost boxed that. We're not quite done. Now what we want to do is, since we're writing in function notation, we want to take our y and replace it with f of x. So we're going to have f of x equals 2/5 x minus 4/5. So this is our equation in function notation. Now they want us to find f of -1. So f of -1 is, well, we're going to take our function and we're going to plug in the -1 for x. So we're going to have 2/5 times -1 and then minus 4/5. Simplifying this down a little bit, 2/5 times -1 is just change the sign, -2/5, and then minus 4/5. Now we already have a common denominator, so we get -2 minus 4 is -6/5. So this is telling us f of -1 equals -6/5. This just means that the point -1, -6/5 is on the line. It's on the line, or the graph of the line that we were given. All right, let's go ahead and try one of these that is not linear. So for this one, we're given x squared minus y equals 3. And so this one is nonlinear. So you don't have to worry about the graph for this quite yet. But this is going to be a U-shaped graph. So let's go ahead and solve for y. Doing the exact same thing, we want to get this y by itself. So I'll get rid of the x squared. Let's subtract x squared. And we have negative y equals, now kind of like with lines, I'm going to put the x in the front. So negative x squared plus 3 because it's positive. And now dividing everything by a negative 1, we get y equals, well, negative over a negative is a positive, so positive x squared. 3 divided by negative 1 is negative 3. Now, we've solved for y, so we want to replace y with f of x. So we get f of x equals x squared minus 3. This is our function notation. Now, if we go ahead and find f of negative 1, we're going to take our function here, x squared minus 3, and replace x with negative 1. So again, this x, I'm going to use parentheses whenever I plug in. So let's put parentheses squared, that's our x squared, and we're going to put a negative 1 in there, and then minus 3. So we have negative 1 squared is negative 1 times negative 1, so that's a positive 1 minus 3, which is negative 2. So again, this means f of negative 1 equals negative 2, which tells us that the point negative 1, negative 2 is on the, I'll put graph this time because this one's not a line. This one's actually going to be a U-shaped graph. Okay, couple more sets of examples here. This next example, we're going to be graphing and then finding the domain and range. So we're told to graph, then find the domain and range. And this is really similar to what we did last time in 9.1. The only difference here is that we're given an equation in function notation. So we're given f of x equals 3/4 x minus 2. And now we want to think of this like slope-intercept form. So remember, y equals mx plus b. The b is the y-intercept, and m is the slope. So that means that in our equation here, our y-intercept is, well, what is our y-intercept going to be? It's going to be 0, negative 2, because it's a point. And our slope, or m, is 3/4. So let's go ahead and graph this one, then we can find the domain and range. Okay, and I'll go ahead and put some tick marks on there. The y-intercept's negative 2 and our slope is positive, so our line's going to be going up. So I'll go out to about 4 or 5 in each direction. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. And 1, 2, 3, 4. All right, so now graphing our y-intercept first, we're at 0, negative 2. So 0 down 2. And our slope is 3/4. So this is saying go up 3, right 4, since they're both positive. So we're going to start at our y-intercept and go up 1, 2, 3. Make sure you count the origin and then write 1, 2, 3, 4. And let's draw our line through those points. So now we have our graph drawn and we want to find our domain and range. So remember, domain is all of the x values, range is all of the y values. So if we look at our x values, that's going left and right. The furthest left that we go, well, this goes left forever, and it goes to the right forever. So what is our domain going to be as an interval? It's going to be negative infinity to positive infinity. And then with our y, remember we want to know how far up and down we go. So the furthest down we go, this line goes down forever, and it goes up forever. So same thing here. Our range is negative infinity to infinity. So this is our graph and domain and range. Okay, the nice thing with this is if you're looking at a linear equation, as long as you have one that's going up and down like this and not a vertical or horizontal line, this will always be your domain and range. So let's go ahead and briefly take a look at an application problem you're going to see in the homework. So for this application, we're told that a bicycle manufacturer has daily fixed costs of $1,934, and each bicycle costs $76 to manufacture. Let X equal the number of bicycles and C of X equals the cost of manufacturing. So they've already given us what X should represent. It's the number of bicycles they're making. And C of X is the cost, which makes sense that it's a function of X because the cost is going to depend on how many bicycles they produce. So part A wants us to write a linear function for this situation. And they've given us that that linear function should be C of X. So we're going to have C of X equals something. So since C of X is the cost, we want to think about what's going into the cost of producing bicycles. They have daily fixed costs of $1,934. Now that's just a one-time daily cost. It's not per bike. So we're going to have 1,934 plus, what is the other cost? Well, each bicycle costs $76, and that's each bicycle. So we're going to have 76 times X. And so this is our function for cost. Part B wants us to find C of 6. Now I'm going to leave this part up to you guys because it's on the homework. Think about what we do with the 6. And then they also want to know, what does this mean? And for that part, think about, you plugged in the 6. That 6 was for X. And what does X represent? Well, X is the number of bicycles. When we have, so when we have 6 bicycles, the cost is going to be whatever you get when you plug in 6. So that'll be the meaning for that one, and I'll let you guys find C of 6 or C of whatever your homework problem is. It's probably a different number than 6. And then part C says find what value of X makes C of X equal 2770, so 2,770. And then they ask, what does this mean? So again, for the meaning, once you've solved it, you'll have an X value and a Y value. Think about what X represents, what the Y value or C of X represents. That'll help you with the meaning. To actually solve this one, they're telling us that C of X is equal to 2,770. So the cost is 2,770, and we get the cost by doing 1934 plus 76x. We want to know what value of x makes the cost equal 2,770. So then all you're going to do here is solve for x. And so again, I'll let you guys do that one. That's an exercise on the homework. And same thing for part B. Part A is also on the homework. Just make sure if you plug this in, the numbers might be a little different in your problem. So you might need to change the numbers, but the setup's going to be the same. Okay, now one last example I want you guys to see because it's on the homework, but I'm going to just give you guys some hints for this one because I don't want to go through and do the whole problem for you guys. It's a really good problem to get you kind of thinking about some of this stuff. Okay, so for this one, we're given the chart. Actually, let's write out the parts over here. So part A in this one, they want you to find f of 4. Part B says if f of x equals negative 0.6, what is the value of x? Part C wants us to find the slope. What is the slope? Part D says what is the y-intercept? And part E says using C and D, write an equation for f of x. All right, so let me give you guys the chart that it comes with, and then I'll give you some hints. So in this one, we have x, and then we have y, or f of x, same thing. So on the left for the x values, we have 0, 1, 2, 3, and 4. And then for the y values, we're given 3.3, 2.0, 0.7, negative 0.6, and negative 1.9. Now, if we go through these different questions here, the first one says, what is f of 4? That 4 is our x value. So this is saying when x is 4, what is our y? So when x is 4, what is y? So for that one, you're going to want to go to the chart, find when x is equal to 4, and see what the y value is. For part B, it says when f of x equals negative 0.6, what is the value of x? So when your y is equal to negative 0.6, what is x? Same thing as part A, just the opposite direction. So if our y is negative 0.6, our x value is, in this case, 3. So this would be 3. Part C, and this is the one that I really want to show you guys, is the slope. Now, for the slope, remember to find slope, we need to use our slope formula, y2 minus y1 over x2 minus x1. And now what I'm going to do is I'm going to pick 2 points from our chart, and it doesn't matter which 2. I'm going to pick these first 2 because the numbers are positive and they look kind of a little bit nicer. So I'm going to have the point 0, 3.3, and 1 and 2, or 2.0. And if we find our slope, we're going to do y2 minus y1. So 2.0 minus 3.3 over 1 minus 0. Remember to go in the correct order. So 2 minus 3.3, if we were to subtract those, we would get negative 1.3 over 1 minus 0 is 1. So negative 1.3 over 1 is just negative 1.3. So for this specific example, our slope is negative 1.3. And remember, your numbers might be different, so make sure you find your slope with your numbers. The y-intercept, well, the y-intercept is the point where the x is 0 and we have some number for the y. So our y-intercept here is this first point in our table. So our y-intercept is 0, 3.3. And then finally, for part E, they want you to write an equation for f of x. For this part, remember that in slope-intercept form, we have f of x equals mx plus b. Now I'm going to let you guys do this part, but remember m is our slope. We got that from part C. And b is our y-intercept, which we got in part D. So you're just going to plug those in. Make sure you have an f of x in the front instead of a y. So that's 9.2. 9.3 is going to be our last section for chapter 9. And 9.3, we're going to be working with functions a little bit more and working with some operations with those functions.